Hello everyone. I am Gargi Mukherjee and our other team members are Maitreyee Chakraborty, Naveen Kumar Singh and Krushnashish Pradhan. We are presenting our project Dumper Truck with Automatic Door Opening Mechanism for the IIT Kharagpur Mechanism Sessional course. The problem we addressed is that conventional dumper trucks use a gravity driven rear door which must be manually unlocked before dumping. This is inconvenient and unsafe. Our objective was to design a mechanism that automatically opens the rear door as the bin tilts without manual intervention. We also aim to relate the bin tilt angle to the door opening angle and allow control over the maximum opening. To begin the synthesis, we scaled down real dumper dimensions. The key inputs were CQ, which took as 320 mm, CO as 100 mm, the angle at C taken as 90 degree, ground hinge spacing AO as 80 mm, and a maximum required door opening angle of 75 degree. Using these, we formulated a 4-bar linkage for door actuation as shown in the figure. Moving on to triangle AOC, at maximum opening, the angle becomes 90 degree minus 75 degree, that is 15 degree. Using the geometric relation AC as L2 plus L3 and OC as L4, we obtained our first equation. Next, in right angle triangle AHB, as shown in the figure, we used AH as L1 minus L3, BH as L4, and AB as L2. Applying the Pythagoras theorem gave our second equation. Solving these two equations simultaneously, we obtained the required link lengths L2 as 100.32 mm and L3 as 71.97 mm. These dimensions satisfy the target door opening angle and allow smooth automatic door operation when the bin tilts. These are our calculations for finding L2 and L3. On this slide, I am explaining how the gate opening angle relates to the bin tilt angle in our mechanism. Here, theta is our input bin angle, which varies from 0 to 50 degrees in small intervals. Based on this input, we determine three key angles, which is the gate opening angle, the angle between link 2 and the ground, and the angle made by link 3 relative to the ground. The sketch on the right gives a visual representation of the link configuration. It shows how these angles interact as the mechanism moves. Essentially, as the bin tilts, each link changes orientation and that determines how much the gate opens. Moving to the calculation, this slide shows the equation used to determine the angles mathematically. We compute beta using a tangent-based expression derived from the geometry of the linkage. The terms A, B, and C come from trigonometric relationships involving link lengths and the input angle theta. Once beta is obtained, we use it in the equation at the bottom to find theta 1, the angle of link 3 relative to the ground. These equations allow us to simulate the mechanism and predict the gate opening for any given tilt angle.
My name is Maitreyee and I am going to explain the MATLAB simulation and code. This is a double rocker mechanism since the link opposite to the shortest link is grounded and satisfies the Grashof condition too. Let's have a look at the code. We have first defined some parameters for the dumper truck. We have selected the values of L1, L4, alpha max, LG, and LC by looking into some real world values and scaling them down. Then by using dead center configuration, we have calculated the link lengths L2 and L3 geometrically. We are finding the remaining values of the parameters by varying the value of theta. In the animation loop, we calculated the final values of beta and theta 1 for each of the values of theta. Then we defined the joint parameters, that is the position of each link, and plotted them in the update plot data section of the code. Let's run the code once and have a look at the simulation.
This is Krushnashish Pradhan, bearing the roll number 23 ME29027. I'm here to present the computer aided design model of the dumper truck whose basic mechanism was shown in the previous section using a MATLAB code. As you will see in the following clip, the operation of the dumper truck is as follows. The pistons move out of the cylinder, which sets the mechanism in motion, which eventually leads to the tilting of the dump and opening of the rear end gate. The retraction of the piston similarly closes the gate and hence lowers the dump. Please pay attention onto your screens for the clip. If one pays close attention, one can see a thin checkered structure attached to the yellow rear gate. The structure in question is a compactor which can be operated independently of the rest of the mechanism and hence is not constrained with them. This is used to press on the contents inside of the truck and keep it at one place. This is useful especially in case of garbage collection trucks where the compactor creates space for more garbage to be filled and also prevents spillage of garbage onto roads and other surfaces. This was the innovation that we have come up with.
My name is Naveen Kumar Singh, 3ME30033. Now let's discuss the degree of freedom calculation. The concept of degree of freedom is crucial in understanding the movement capabilities of mechanical systems. Degree of freedom analysis, excluding the compactor. First we exclude the compactor, then we calculate that the number of links are 6, the number of joints are 7. Then doing the calculation, then we obtain the degree of freedom value to be 1. In this mechanism, there are 6 evolved and 1 prismatic joint. Including the compactor, the number of links are 7, the number of joints are 8. Summation of degree of freedom of individual joints is equals to 8. Then we obtain the degree of freedom to be 2. 1 degree of freedom extra as the compactor move independently of the rest of the mechanism. Now coming to the conclusion part. To wrap up our project on the dumper truck with the automatic door opening mechanism presents a significant advancement in design and functionality of dumper trucks. Here are the key takeaways from our work. Innovation mechanism. We developed a mechanized door opening system that operates automatically as been tilts, eliminating the need for manual intervention. This innovation not only improves efficiency but also enhances safety for our operators. Second is robust design. Through rigorous calculation and simulation both in MATLAB and Solidworks, we ensure that our design is robust and capable of withstanding operational stress. Degree of freedom, our analysis revealed critical insights that the mechanism movement capabilities, highlighting the importance of a flexibility in design, especially with the inclusion of the compactor. Now, coming to the future improvements, while our current design is effective, we recognize the opportunity of our future enhancements. For instance, we could explore incorporating an automatic locking mechanism that engage when the bin is in horizontal position, ensuring safety during transport. In conclusion, we believe that our project has the potential to set new standards in dumper trucks design, paving the way for more automated and efficient construction and mining. Thank you.